Hello my dear students, good evening to all. This is my part 2 video continuation of universal quantifier. Let's see the other logical operator combinations with the given example. Okay, every square number is non-negative and divisible by itself. So after reading the statement, just to find out whether the given statement is possible or impossible, which means either true or false. So every square number is non-negative and divisible by itself. It's a positive. For every number x, if it is square, then two properties must hold simultaneously. The and means both conditions must be true for each element. It stands for every, so it comes universal quantifier concept. For every x, for every x, for every x, if x is a square, this is a square, then square number, then x non-negative, and divisible by itself. Oh, sorry guys. By itself. Okay, so now convert one more easy statement. So I can, as we know, for every x is the belongs to universal quantifier symbol. So now I can consider the square. First letter I will take s of x. X is a square. Next I will take, then x is a non-negative. I'll take first character n of x. X is a non-negative. Next and if, then obviously if then keyword if you find means that is implication. And means is an and operator. Let's see that n of x is non-negative and divisible by itself. I will take the first character d of x. Divisible by itself. So this is the next step before converting the symbolic form. Write a title here. So I can take for every x is universal quantifier symbol. Open bracket s of x, implication n of x, and operator d of x. Close bracket. That's all. So this is for every x. If x is a square, then x is non-negative and divisible by itself. This is the way you have to convert the statement into the symbolic form. Let's see another example also. So here obviously it is involved implication operator as well as the and operator. Okay. So let's see that another example. No employee is both absent and present at the same time. Okay, now analyze this statement. Is it possible or not possible? No employee is both absent and present at the same time. It is impossible. So obviously the statement is false. This is a universal negative statement. It states that for every employee, the combination absent and present is impossible. So how to convert the statements? Let's justify here. For every X, if X is an employee, and if X is absent, then X is a employee. X is a person, employee, not present. So this is the conversion. So don't think the statement and is involved. So immediately don't conclude. Everyone should point out whether the statement is possible or impossible, true or false. Then you can conclude whether and operator is involved or not. So convert to the easy format. Then for every X, if X is employee and if X is absent, then X is not present. So never will happen. This is impossible things. At a time, no employee will make absent and present. So how to convert with another easy step? You can split the sentence like this also. So, as we know, universal quantifier is for every X. I will use different color pen. Next, I am going to conclude an employee. So I will take the first character E of X. So E of X is X is employee. Next, I will consider absent E of X. X is absent. Next, I will consider present P of X. X is not present. Okay, now convert to the symbolic form. Okay. So first take for universal quantifier, open bracket. If X is an employee, E of X. If X is an employee, implication. And if X is absent, E of X, then to implication. Then not absent. Then P of X, that means not present. So E of X is a employee, E of X is a absent, P of X is a not present. So you have to bring the not symbol here, close bracket. Or you can write another version also. If present, they are not absent. So universal quantifier symbol, employee of X, X is an employee, implication. If they are present, definitely not absent. E of X, close bracket. So you can write this two way also. Okay, so here obviously two operators are involved, two implication and not operator. So two implication and not operator, even and is here, but we are not considered and, that and is not belongs to logical operator and. So that's what always we need to verify the statement is possible or impossible. Based on the way you have to predict whether it is a belongs to which kind of the operator. Okay, let's see the next example. No student is absent. Very simple statement. This is the last exercise, students. No student is absent. So the statement is whether it is positive or negative. No student is absent. This means for every student, the property absent is false. So obviously the word we got no from beginning itself. Let's see that no is become a not operator or not. Convert the easy sentence. For every X, if X is a student, then X is not absent. So obviously for every X, if X is a student, then X, the student not absent. It may happen absent cases, but it is not strong. Again, S of X, X is a student. Next I will take not absent. So I can take for A of X. X is a not absent. Okay. Now convert to the symbolic form. Open bracket. S of X, implication, not absent. Sorry guys, I will write it again. This is the answer. Not this bracket, this bracket. Yes. So how we are written? This is for every X. For every X. This is my student. X is a student. If then, the keyword if then is involved. So implication, if then, not absent. Not absent. So this is not. This is absent. X is not absent. Okay, this is task for you. Every real number is not negative. Can you please work out this exercise? And let me know the answer in the comment box. That's all. Thank you. Thank you.